Good day, fellow students, and welcome to our screencast. We are first year BTech quality students at Cape Peninsula University of Technology. Our screencast will cover the topic of binomial probability distribution. And this presentation was prepared by the following students: Tamlin May, Odette France, Samantha Pologan, Lamlin Ntandiso, and Roxanne Williams. The content of this presentation will cover the following: introduction to statistics, branches of statistics, introduction to basic probability, binomial distribution, conditions of binomial distribution formula, derivation of binomial distribution formula, examples, and lastly, application of binomial distribution in quality management. What is statistics? A branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data to assist in making more effective decisions. Statistical probability tools enables organizations to monitor processes to ensure conformance to customer specification. The use of tables, graphs, and charts play a vital role in presenting the data being used to draw these conclusions. The study of statistics has two major branches, namely descriptive statistics and inferential statistics. In inferential statistics, it is a large variety of techniques that allows us to make claims about population based on sample data. Descriptive statistics is to organize, summarize, and display data so that we can quickly obtain an overview. Descriptive statistics report only what was observed, whereas inferential statistics makes a claim about a population based on results taken from a sample which is part of a population. However, it is very important to note that binomial distribution is equal to descriptive statistics. It is vital that we first introduce basic probability, as it is the foundation for binomial distribution. The probability is the number that reflects the chance of or likelihood that a particular event will occur. It is given by a number of successful outcomes divided by total number of possible outcomes. Probability is always expressed as a number between 0 and 1, or can be represented as a fraction. Can also be expressed as a percentage from 0 to 100. Looking at basic probability rules. If you're looking for a probability of doing this or that, you're gonna add the probabilities. And if you're looking for a probability of doing this and that, you're gonna multiply the probabilities together. Now, what is binomial probability? Binomial probability is a type of probability distribution in statistics that has two possible outcomes. Hence the word binomial. It means there's two events. It describes the possible number of times that a particular event will occur in a sequence of observations. Whenever using binomial distribution, we must clearly specify which outcome is the success and which is the failure. In quality terms, the outcomes can either be compliant or non-compliant, in specification or out of specification. When one is dealing with binomial distribution, it needs to satisfy the following conditions. There are a fixed number of trials or experiments. Each trial has two possible outcomes, either success or failure. The probability of success is the same of each trial. The trials are independent, meaning the outcome of one trial does not affect the other. Binomial formula, where C is a combination of binomial coefficient. S is the probability of a successful event. F is the probability of a failure. N is the total number of outcomes, and small n is the number of desired outcomes. Now let's look at the derivation of probability formula. Here we'll just explain the combination and exponent to S and F found in binomial probability. Here we look at the trials versus possible outcomes. One trial has two possible outcomes, success or failure. Two trials has four possible outcomes. Three trials has 8 possible outcomes. 4 trials has 16 possible outcomes. In explaining this table, let us place together represent and AND this equation. SF means a success, followed by a failure. Similarly, FSS means a failure on the first trial and a success on the second trial and a success on the third trial. And it's explaining where does the exponents come from. The algebraic form simplifies the situation. In the case of 4 trials, 4 consecutive successes can be written in exponential form as s to the power 4. Repeated trials form an AND situation and leads to a multiplication. We've seen that from the probability theory that was explained in the earlier slide. A repeated multiplication is a power. The OR situation leads to addition. Looking at the probability of finding 3 successes and 1 failure can occur in 4 ways. And this is simplified in this algebraic form. Now let's explain how do we get to 4. Because 4 is the number of ways or number of arrangements that we can get 3 successes and a failure. Looking at table 1. Table 1, getting 3 successes and a failure is either we get 3 consecutive successes and a failure, or 2 consecutive successes, failure and a success, or a success followed by a failure and 2 successes, or a failure followed by 3 successes. And when you add this using the basic probability rules that we explained, the OR is gonna be an addition. So when you add these, you get the number of ways you can get 3 successes and a failure. Now let's look at an example. The production manager of Bobtail Dog Food Manufacturing Company examines the data of the protein measurements and wants to know the probability of finding 3 samples that are out of specification limits when sampling 10 products with displacement. Firstly, when you're looking at this problem, you must first determine which is your success and which is your failure. By doing that, most of the time your success is given in the question. In this case, your success is to get 3 samples that are out of specification limit, and the rest will be your failure, which is your failable 7 and the success is 3. And the total number of n, which is number of trials, is 10, and the number of desired successes is 3 and is given by this combination. Now let's jump to Excel to do the calculations. Excel is a very good tool to use when you're analyzing complex data. Here are the measurements taken by the manager, which is there are 40 measurements taken by the manager, and with your limit, lower specification limit of 36 and upper specification of 44. So we want to know the outer specification results. We must start calculating the below spec, which is what is below 36. To calculate that, you do cut then you select the entire range of observations because you want to know what is below 36 in this range. And then you put your 36. It is below 36. And then what is below 36 is 5 observations below 36. And then let's copy that. You want to find what is above specification. But what is above specification, which is above 40 in this case, which is greater than 44, my pardon, but 44. So there's 3 observations that are above specification. So your outer specification is the total, which is your below spec plus your above spec. And there's 8 number of observations that are out of specification, and your in specification is your failure, which is the rest, is 40 minus your out of specification results, which is 32. So by having this, you can calculate all the variables of the formula. To calculate the combination is given by combine, and Excel does it for you. If you just type it, guides to the formula combine, and then your big N is 10 and your small n is 3. Then you've got 120 number of ways of getting 3 samples that are out of specification, and probability of finding a success is given by 8 divided by 40, so your total observations, and your failure is given by which is your failure, divide by total number of observations 40. To calculate your power, it will say equal to power, open brackets, even in this case, guides you Excel, power, open brackets, which is what you want, power, which is 0.2, your probability of a success, to the power 3. Just forgot the power, there you are, choose power. This is your answer, and then calculate that, is also type power, open brackets, and then your probability of a failure, and to the power 7. So just plug all the values that you've got for these variables of the formula. So now your combination is 120 times your success to the power 3 times your failure to the power 7. Then that's your answer. Now looking at the answer, then the manager needs to make effective decision using the answer that he got. So even though this probability answer is not alarming, but no management wants to have an auto-specification products. So management uses statistics to make effective decisions and to make improvements in their company's work process. Therefore, for continuous improvement, management may take actions on what he has discovered based on the data analysis. Try to determine the causes of the auto-specification products. Eliminate the causes by improving resources. Make changes to the quality management system by designing new methods. Plan again for a new product development. Now, application of binomial distributions in quality management. In manufacturing, line managers may use probability distributions to generate sample plans and predict process yield. Sample plans simply means it's a detailed outline of measurements or data taken. And process yields are products that meet customer specifications and produced without rework. In finance, fund managers may use them to determine the possible returns a stock may earn in the future. Insurance managers may use them to forecast the uncertain future claims. Restaurant managers may use them to resolve future customer complaints. And it can be used in quality control environment where industrial engineers are interested in the proportion of defectives. Now, in conclusion, we have found that binomial probability is a probability model which is used when there are two possible outcomes, and those possible outcomes can either be success or a failure. Binomial distribution is used when we want to know the occurrence of an event, not its magnitude. It enables organizations to compute the probability of observing a specific number of successes when the trial sampling is repeated a specific number of times, where the outcome is either success or failure. Binomial probability is a quality tool that can be applied to many different types of industry in order to design appropriate models which can be used to make inferences and predictions for continual quality improvement. The following list are the references that we used to compile this presentation. This is statistics